Hello, my name is Jared Skeens and welcome to the Zoom room. Today we want to cover Pure Math 1 Functions, Part 3, Sketching the f of x function and the inverse of f of x function on the same graph. Now, even though this is referred to as sketching the graphs, actually the most important part of the lesson isn't so much the sketching, as Cambridge doesn't often ask you to sketch the graphs. It does occasionally, but it's not a significant portion of their question types. So don't focus specifically on the sketching part itself. What you really need to focus on are these three relationships over here. The relationships between the function and the inverse function. This is kind of like training your mind to understand how math correlates or interconnects. And that is going to be important for you moving forward. Like I said, it's not so much the sketching. There are a couple of questions that ask for sketching algebraically. There's also a couple that ask for sketching with trigonometry that you'll get to in the trigonometry unit. But what's extremely important, these relationships, especially number 3 that deals with the domain and range. We're going to have a separate video just to go over domain and range, because domain and range apply to several different things, not just inverse function. But you'll really give yourself a head start if you focus on these in this video, get your mind around them, and then as you move forward, hopefully you'll be able to make those connections that you need to. A lot of times those domain and range questions are just worth 1 point because it's not really a skill, it's more an observation or a mental understanding that you should be able to answer right away without doing a lot of work. So your mental understanding of the relationship between functions and inverse functions really comes right here. The sketching just helps give a visual, the visual representation, maybe helps you to see it a little bit better. So it's good to have the sketching as part of it. Only have 2 examples for you, okay? But first, let's look at these 3 relationships. Here is our regular function f of x. Over here is the inverse function. Now, in part 2 of our series, we looked at how to find the inverse. Now we want to understand the relationship between the function and its inverse. So the very first relationship that's important to understand is that a coordinate, an xy coordinate that is on your function graph will be flipped around and it will be on the inverse function graph. Okay, we'll see this when we get into the sketching. So on the f of x function, a particular coordinate is xy. On the corresponding inverse function, it will be then yx. And this should make sense because the first of our skill steps in finding the inverse was to switch your x and y. And so we see that happens also with the values of the coordinates. The second thing that we find, the relationship between function and inverse function, is that when you graph them, they will be symmetrical over this y equals x. Okay, this y equals x follows your y equals mx plus c, where the c is an understood 0. It means it crosses the y-axis at the origin. And the m is an understood 1. Your slope is up 1 over 1. So all of these points are going to have identical xy values. So 1 on x is 1 on y. 2 on x is 2 on y, and so on. So this is an important piece of information that we also see when we find points of intersection. Our two graphs, if they intersect, they will intersect along this line right here, meaning any point of intersection will have the same x, y value, like 4, 4 or 7, 7. They'll be the same values that land on this if they intersect. Okay, so this is symmetrical over the y equals x. And notice when I draw my graph, that's the first thing I put in. It's a point of reference to help you with the sketching. And if you don't know how to draw it, well, remember it's y equals mx plus c, crosses at the origin, slope up 1 over 1. It makes a 45-degree angle with your x-axis. Cut your x and y-axis right in the middle. So just put that dotted line. It means an imaginary line. It just helps you with the sketching. In case your graphing skills is still maybe a little weak, this can help. So these first two, again, it corresponds with how to find the inverse. You switch x and y. It helps you with understanding what's happening graphically as it reflects over the y equals x, can also help you with points of intersection. These two here are more important if you have to sketch. It will help you. The third one, it's not quite as important for the sketching part, but it is extremely important in understanding the relationships with domain and range. So after this video, when we go into the domain and range and talk about it more in depth on how it applies to a lot of things and functions, this relationship of the two will be extremely important. And what we see, a regular function will have a particular domain. That is, x will fall between two particular values, or it might be like this, that it is just all real. But there will be a domain statement that states the domain of your function. There may not be a range statement. Usually in algebra, they give you domain statements. They don't usually mention the range. There are ways of finding the range. The range is usually a little bit more tricky to find than the domain is. The domain is quite easy to find. But if they do happen to give you the range, or they give you the domain like this, where it's particular values, you can plug this A and B into your X, and you'll get the corresponding Y. So if you plug the A in for X, you get a particular Y value. If you plug a B in for the X, you'll get a particular Y value. And usually, that will become your range. There's a few exceptions with that. Like I said, range can be a little tricky at times, but you can determine the range if you need to. But if they give you the range, that's even better. Now, as you move from the function to the inverse function, your domain and range switch. Just like your x and y switch, your domain and range also switch. So for whatever values that x was allowed in the domain, now become the values that y is allowed for in the range. And the values that the y was allowed in the range become the values that the x is allowed in the domain for the inverse function. Okay, now I've verbally explained it. Let's visually see what this looks like in a couple of examples, because like I said, it's not so much the sketch, although it is important too, but what's more important is the concepts behind it. Okay, so here we have a function that f of x equals 4 minus 5x. Hopefully you recognize that as a linear function. It's just out of the normal order. Here we have y equals, here's our mx. So the slope is a -5, and the c is the +4. That's where it crosses the y-axis. The domain statement is all reals, meaning the line can continue on in both directions. So the first thing they want us to do is find the inverse function. Well, it gives us an opportunity to practice what we covered in part 2. So I'm going to do it over here. And so we have y equals 4 minus 5x. First thing we do is we switch x and y. X equals 4 minus 5y. And then we solve for y. So we need to subtract 4 from both sides. So we get a -5y equals x minus 4. Then we need to divide both sides by our -5, which I'm just squeezing in there at the bottom. And this cancels, and so what we end up with is y equals, now notice we get an x minus 4 over -5. Couple things to remember. First, don't leave it as y. Make sure you change it back into the inverse function notation. So we're going to change it back to our inverse function. Second thing is the form of the answer. Technically, doesn't really matter. Practically speaking, it can be helpful for you if you do a couple of things. First, this negative on the bottom, most math people don't usually like to leave a negative in the front. So what you can do is you can take this negative from the bottom and you can multiply it through the top. In other words, a fraction is negative regardless of whether the negative is in the numerator or the denominator. So you are free to choose which place you want it to be. So I'm just moving it from the denominator so that the denominator can be positive, and I'm distributing it through the numerator. So this then will become a -x plus 4. And again, and you're going to have to decide what you want to do with this. Our goal is for graphing. So if I were just going to leave it as the fraction, I would change it around to 4 minus x so that the positive is in the front. See, math is about thinking what you want to do, not just doing stuff randomly. So now that I've moved that negative through the top, I actually don't want to put the positive in the front now. And my reasoning is this. I want it to look like a graph that I know how to sketch. So what I want to do is distribute the 5 through, break this up so that it looks like a line, because I know how to graph a line. So this is going to be a -1/5 x plus 4/5. Okay? So now this follows y equals mx plus c. So from a sketching point of view, this form is a little bit more friendly than this fraction form here. So think ahead to what will help you in the particular problem you're dealing with. Okay? Technically, like I said, there was nothing wrong with x minus 4 over -5. There's nothing wrong with distributing the negative to the top. And you could have also moved the positive in front, which sometimes I do, but not for sketching. Sketching, I want y equals mx plus c format. Okay, so you need to see the different forms that can arise out of what you're working with and select the one that is most conducive to graphing. So now we have this one. I'm going to bring this one down to here. Actually, I need a little bit more space because we want to find the point of intersection. So I'm going to bring this one down here, actually, get it out of the way. so we can see them side by side. And I'm going to arrange it into the y equals mx plus c. So a negative 5x plus 4. Okay. And hopefully, if you look at this form right here, you can see that we've done opposites. Remember, inverse function is the opposite of the regular function. So if you look at this form right here before we did all the changing to it, you can see that here x is multiplied by negative 5. Here you see your x is divided by negative 5. Here you see you have a plus 4, and here you see there's the minus 4. So if you look at this one here, you can see that opposite connection. Again, we've rearranged it into a graphing format. So we'll get to the graphing in just a minute. There's a second part of this first question that we need, and that is to find the point of intersection. So that means our function, if it intersects, has to equal the inverse function. So we're going to take our negative 5x plus 4, set it equal to our negative 1/5 x plus 4/5. Well, to solve this, we want to first get rid of those nasty fractions. So multiply everything by 5. Negative 25x plus 20 equals a negative x plus 4. So if we add 25x to this side, that gives us 24x. Okay, so we're adding 25x to a negative x, gives us 24x. Subtract 4 over here gives us 16. And I feel like I missed something somewhere, but that's okay. Let's see what we get here first. And we divide by 24. X equals, these are divided by 4. 4 over 4 times 6, or 2/3. So we get x equals 2/3. Now, if we want to double check to make sure that we haven't made a mistake somewhere, I was feeling a little bit like maybe something's not right. Well, we can check this out to see if everything's okay, because if it's symmetrical, the y should equal x. In other words, if it's intersecting, it will intersect on this line. So if we solve for y, we should also get 2/3. If we get 2/3, everything's okay. If we don't get 2/3, something's wrong. Okay, so let's plug it back in to say up here, 4 minus 5 times 2/3. So this is 4 minus 10/3. Well, 4 over 1 times 3, if you get common denominator, gives you 12/3 minus 10/3. What do you know? It does equal 2/3. So now I feel better. I was a little worried because we're going to get fractions, but the important thing is your x equals your y, because here's our basically y equals, almost running on top of my work over here. So I hope you can follow that through. So the y equals 2/3. So we found the inverse function right here. Okay, hopefully you can separate the work here. We found the inverse function. We solved for the point of intersection, and our point of intersection is 2/3 and 2/3. Now I'm going to erase this, or I'll just put it down here, I guess, so I don't have to take up time erasing. Our point of intersection is 2/3 and 2/3. I'm not going to put 2/3 on the graph right now. Remember, sketching is not about perfect accuracy. It's about the general picture. So after we draw the picture, we'll look to see if 2/3, 2/3 is roughly where it's supposed to be. Okay? So what we want to do now is we want to sketch both of these functions, the function and inverse function, on one graph. It's important that you put them on the same graph so that you can see what's going on. Do not put f of x on one graph and the inverse function on another graph. I've seen students do that. It's not what it's asking for. It wants them on the same diagram. Okay, so notice the first thing I do is I put in, other than drawing the xy axes, I put in the y equals x imaginary line. Then let's look at our function, follows the y equals mx plus c. So plus c is 4. 1, 2, 3, 4, and put a dot. And the slope is a -5. That means down 5 over 1. So down 5, and this is an understood over 1. So that puts us right there. So this graph is a little bit difficult to draw. It's coming down through here, and put arrows on both sides because it's all real, meaning it's going on forever. So I'm just going to label these points. This is the point 0, 4, and this one that we came up with down here is the point 1, -1. 1, -1. Okay, so 0, 4, 1, -1. Now we want to draw this other one. This other one is at 4/5 is where it crosses the y-axis. 4/5 is almost to 1. And it has a slope of a -1/5. So down 1, and over 5. So if we go, we already have 1, 2, 3, 4, 5. And if we go down 1 and over 5, we're about right here, okay? So our graph is going this way, like this, okay? So that's our graph, 4/5, and that one's a little bit more tricky because it's fractions. So if you look, notice it's not perfectly accurate, but you can see that we are pretty close in our intersection with our y equals x. Like I said, sketching is not super accurate, especially when you're dealing with fractions. You know, it's really difficult. And when you're freehanding the graph, now Cambridge will, or probably will, provide you with graph paper in the exam. If they don't, then that means your freehand has a little bit more leeway to not be, you know, exact. If you were using line graph, this would be closer. But you can see that our point of intersection is roughly on that y equals x. My y equals x might be slightly off. Maybe one of my lines is slightly off. But if you just make this a nice big point right there, they are intersecting roughly on the y equals x, and it is approximately 2/3 by 2/3. So that's what's important in a sketch. Don't feel like you have to have it perfect. You don't have time on a Cambridge test to make your sketches perfect. That's why it's a sketch, not a graph, technically speaking, okay? So notice again, let's say, here's another thing on our graph that we should look for. Again, the fact that we're dealing with fractions is going to make it a little bit more difficult. Notice this is 0, 4. Now, it should be at 4, 0 is where this blue line should be crossing. Notice my line kind of dipped a little bit right here. It should be a little bit more like this. Okay, but that's one of the things you're looking for. You're looking for that 0, 4 becomes 4, 0. Okay, my point here might have been a little bit low. Maybe it should have been a little bit higher. Like I say, you're working with fractions. Okay, that's another thing. Here you have 1, -1. So if you have 1, -1, then, and you switch that, then it should become -1, 1. And if you look here at -1, 1, yeah, that's pretty close right there. -1, 1. So when you switch your X and Y, it should be on the other graph, okay? So our 0, 4 becomes 4, 0. That one I didn't quite do so hot on, but our intersecting point was relatively close, and our 1, -1 was pretty good. But that's one of the things you're looking for, your symmetry over this. You can see now the symmetry means that if you fold this side over to this side, this line right here actually becomes this part over here, and this part here, when you fold it over this line, actually becomes this one down here. So you should see the symmetry. Again, you're just folding the graph over, and you should see it show up on the other side of the fold. Okay, so we got the symmetry down. For the domain and range, in this case, the domain and range, I'll show you better on the second example. This one, because it's all reals, means that the range is also all reals. It's going off in both directions, so we don't really have bounds to look at, and we'll look at that on the second example. Okay, so again, sketching, yeah, it's important. You're following linear graphing. You should be able to do that. Doesn't have to be perfect, but it should be close. This is the most important, the concepts behind it. I hope you're starting to get it. We'll do one more example, and hopefully that will help you. Okay, here we go with our second example. It'll actually be our last example. I've already done part of it for us. So here's what they give. They give us the original function. Now, notice the original function has 2 parts. This is called a piecewise function, meaning it takes like 2 different graph types and like splices it together. Notice here you see one part is linear, that's the 3x minus 2, and you see that this other part is this inverse or reciprocal function type graph. Now, these 2 graph pieces are spliced together. You have the line and this reciprocal function. Now, in the Cambridge question, this part of the graph, which is our f of x graph, is provided. They do not provide this line of symmetry, the y equals x, and they don't provide these points. I have added those in. Okay, so let's just look at that really quick. F of x equals 3x minus 2. That's the line. Crosses the y-axis at -2. Okay, and has a slope of 3. 1, 2, 3 over 1. And also you could go down 3, back 1. You can see that this follows this line. And its domain is said to be from -1, that's the starting point, all the way until x equals 1, and that's the ending point. Then this is connected to, notice your domain just continues on from -1 to 1 and then picks up at a 1 again and goes from 1 until 4. So this part will be this reciprocal function graph. And maybe you don't remember from reciprocal functions, maybe you're not familiar with that graph type, but it basically comes around here like this. Now, how do I get these coordinates? Because it wasn't supplied in the graph. Well, I plug in this -1 here, or these parts. This is on here. So if you plug in 1, 5 minus 1 is 4. 4 divided by 4 is 1. If you plug in 4, 5 minus 4 is 1. 4 divided by 1 is 4. So you can see that this is the point 4, 4, and 1, 1 on this graph, that these are on this point of symmetry. Now, actually what the first part asked was the range. And we haven't really gotten into the domain and range. I've been kind of waiting for you to understand other things first. So how do I get this range? I provided it for us. Well, again, you take the lowest and highest value, the -1 to the 4, that's our domain, and this is going to give us the up and down. Notice our graph that the lowest point is over here corresponding to our -1, and the highest point on our graph is over here corresponding to the 4. So I plug those into their appropriate part. Can't plug this one in here, and you can't plug this one in up here. It has to go into the section it correlates with. So if you plug in a -1, you get -3 minus 2, which is -5. If you plug in 4, you get 5 minus 4 is 1. 4 divided by 1 is 4. So notice the domain is going from -1 over to 4. The range is going from -5 up to +4. Range is your Y values. Domain is your X values. So it asked for the range, and I went ahead and provided it for us because we haven't really, we're still working on discussing domain and range. And then it's going to ask us to sketch the inverse function. It actually asks us to sketch it before it asks us to define it. Meaning they want you to sketch it not based on what the actual formula is. They want you to sketch it based on the relationships between function and its inverse. Okay, so that's why I added some of these points. We know that if you plug in 4, you get 4 as your answer. And if you plug in 1, 3 minus 2 is 1. You get 1 for answer. So plug in 4 here. And actually the 1 you could plug in either one. It doesn't matter. It's shared by both. Plug the 4 in here. 5 minus 4 is 1. 4 divided by 1 is 4. Plug in the 1 here if you want. 5 minus 1 is 4. 4 divided by 4 is also 1. If you plug in the 1 up here, 3 minus 2 is also 1. So the 1 is shared by both. It can be plugged into both. Technically, the equal sign is not here. So technically, you're supposed to plug it into this one. But since they connect, obviously, it should also work on that one as well. So I put 4, 4, 1, 1. I also identified this because it happened to be the y equals mx plus c. So it's crossing the y-axis at -2, 0, -2, 0 on the x, -2 on the y. And when we get down here, this point down here is our point -1, -5. So if we look here, we have at -1, our range goes down to -5. So this is the point -1, -5, furthest left on the domain, furthest down on the range. So if you can identify those points, it's helpful because all you have to do is flip the coordinates. You flip the coordinates, you automatically have your inverse function. So if you flip 4, 4, well, guess what you're going to get? You're going to get 4, 4. And if you flip 1, 1, well, guess what you're going to get? You're going to get the point 1, 1. If you flip 0, -2, well, you're now going to get -2, 0. So let me put -2 here. So there's going to be a dot there. And if we flip -1, -5, we're going to get -5, -1. So that's going to be the point roughly right here. So now all you have to do is graph this with a little bit of symmetry to it. So if you fold this over, well, this is just going to make a kind of a ball shape here. This is just going to go over like this, Just make it somewhat symmetrical. And then it's going to go outward towards these other points in a straight line. Didn't do that very good, did I? Kind of missed my point. Okay, so straighten that up a little bit. Like I said, it doesn't have to be perfect, but it should look good. So we use the concept of switching X and Y and the concept of being symmetrical over the Y equals X. And we were able to graph, this is now our inverse function, without even knowing the formula for the inverse function. Okay, that's what's really important, is that you understand these concepts. Okay, now it did ask for us to find the inverse function. Well, we actually covered that in part 2, so I did it for us really quickly. Here you see 1/3 x plus 2/3. You can see it crosses at roughly 2/3, and if you go up 1 over 3, well, it kind of is off the domain. If you go down 1 back 3, you can see, yeah, it's roughly down 1 back 3 is about right. And then this one again is our reciprocal function. Maybe you're not as familiar with, but it just gives us that graph right there. So you see that the X and Y switch. You can see the symmetry. And what's really important for you moving forward as we get on into the domain and range, you really need to get comfortable with what you're looking for in domain and range. What's important is, because it asks us to define the inverse function. Well, this is what it means by the definition. It means find the inverse function. What are the equations of the inverse function? So this is a piecewise, again, equation has 2 pieces to it, corresponds to these. I already showed you in part 2 how to find it. I did it for us. What's important now is the set of values that make it valid. That's referring to this. So what is the domain of this? Well, all you have to do is look for this. Remember your domain and range split or switch. So our range for this one, if we were to do a range, our range for this one, by just looking at this, our range should be from -1 to 4. Well, let's look at it. Our lowest Y value is -1. Our highest Y value is 4. See, it works. You just switch your domain, which is from -1 to 4, now is the range for our inverse function. Okay, so just make that a little bit better. Now, the domain is going to be from -5 to 4, but in pieces. So this one is still, this part down here is still from 1 to 4. Because here we see 1 to 4. Now, it didn't have the equal to on this one, so I'm not including the equal to on this one. This one is from 1 to -5. This is -5 out here. So -5x to 1. This one I can put the equal to on so that there's an overlap here. And so notice the total domain is from -5 to 4, which corresponds to the range of the regular function. Okay, so the range of the regular function corresponds to the domain of the inverse function. The range of the inverse function corresponds to the domain of the original function. This is an important concept for you to grasp, because oftentimes they're going to ask you domain and range questions that relate to function and inverse function. You don't have to do any math. You just, or the only math that you need to do might be just to plug in like this -1 and 4 to get those values. But if it's asking for the domain, Well, the domain is going to come from the range. If it's asking you for the range, it's going to come from the domain. It's that correlation that's going to be important for you to get those particular questions that they throw in. They're only worth 1 point, but you add up all those 1 points on a Cambridge test, it can be very important to your grade boundaries. You don't want to lose those little points. So I hope you're really focused on these relationships. The sketching, fortunately, it's not a major question type for them. I only gave 2 examples. And piecewise functions, don't worry about that. Just take them one at a time and put them together. They don't have to be scary. They're separate. So they did provide one graph, you provide the other graph. Again, it was not by the formula, it was by the concepts. Your mental concepts with functions, especially with domain and range, that's what's going to help you be successful. And we'll see how it works as we move forward into the video on domain and range. So I hope this helps, and thank you again for joining me in the Zoom room.